For today's Weather with Ag Weather Network, we have three speakers. We're going to talk about the cold hardness models for grapes and blueberries. Some of these models are developed through Commodity Commission funding, and also for grape, we have one of the model that is developed through AgAid efforts. AgAid is the institute that is funded through USDA and NIFA, and we're trying to bring AI into agriculture. And then, so in terms of the grapes, Professor Michelle Moyer is going to talk about the basics and then introduce the models. Professor Gwen Heisel is going to take care of the blueberries. And then we have another funded project through USDA NIFA, Cyber Physical Systems. Therein, Shrikant, one of the graduate students, is comparing different ways to quantify the cold hardness or frost susceptibility in blueberries and sweet cherries. So he's going to talk about how we can use either air temperature and bird temperature data and how to make sense of some of those. With that, I think I'll have Dr. Michelle Moyer start sharing her screen and get going with the grape cold hardness models.
Perfect. Can you guys see my screen?
Yes.
Perfect. Because as soon as I do that, all you guys go away. So hopefully there's no major questions in this. So thank you, Lav, and thanks everybody for attending today. I'm very excited to talk about grape cold hardiness with Weather with Ag WeatherNet, which is a fantastic title. Could also be a podcast, Lav. So keep that in mind for the future. That'll be fun. So in the short 10 minutes that I have with you guys to talk about grape cold hardiness, I'm going to go through two things. First, we're going to walk through how to access the various grape cold hardiness models on Ag WeatherNet. And then we're going to talk about how we can use that information from those grape cold hardiness models to make farming decisions, such as pruning or crop load adjustments based on whether or not cold damage has actually occurred in grapes. So for those of you who grow grapes, you already know this. For those who don't grow grapes, one thing to remember when we talk about grape cold hardiness is that grapes, particularly wine grapes, are a temperate climate crop, meaning while they do survive colder winters, there is a point where certain winter temperatures get too cold for them, and we have what we call mid-winter cold damage. So that's what we refer to when we refer to cold hardiness. We're not referring to frost damage that happens once there's actively growing tissue. We're referring to damage that can happen to the plant when it is dormant during the winter months. And fortunately, with Washington, we really do have a great climate for wine and juice grape production, but there are certain winters where it gets a little too cold and we can have damage in our cropping systems. And because of that, it's nice to be able to better understand when damage might have actually occurred in a vineyard, so then we can make subsequent management decisions. All right, so getting into what grape cold hardiness models are available to us. So I'm going to turn my face over because I'm going to be looking at the screen. So hopefully that isn't distracting. But if you look at the screen here, what you are seeing is a shot of the Ag WeatherNet landing page at weather.wsu.edu. Many of you guys see these familiar images. You may or may not have your system customized to you, but once you log in, hopefully this is what you see. You can unlock and lock major maps to scroll through and find all your stations. I'm sure Lav has gone over that with you guys in various other presentations. I tend to like to lock things so things aren't moving across my screen. But if you're looking for where the grape cold hardiness or any of the cold hardiness models are housed, once you are logged into Ag WeatherNet, all you have to do is jump over to the left-hand side of your screen, and you're looking for the word models, because these are cold hardiness models. So that would make sense that they'd be housed under the model tab. When you click on models, two parts of your screen change. One, the left-hand side might change, and you see all sorts of different models available for heat and chill units, for animals, for all sorts of different crops, and for irrigation, and also for humans. Those are also populated on the main landing screen, depending on how you like to navigate through websites. I find it easier to use the left side, so I'm going to do that. And we're going to click on Grape because we're interested in grape cold hardiness models. Once you click on that, you'll see three different model types available on Ag WeatherNet: grape cold hardiness, grape powdery mildew, and grape development stages. Today, we're going to talk about grape cold hardiness. So just click on that hot link and it'll take you to the cold hardiness model pages. All right, so before we get into what the model actually is, I want to navigate through the page itself, because most of the time, let's be honest, many of us don't take the time to do that when we're playing on a website. And so now you can do this during this presentation. I'll go through it with you, and then you don't actually have to look at that again unless you need the information. But the first thing to notice when you land on the grape cold hardiness page, it describes what you are going to be seeing on this page, and that you will be seeing two different grape cold hardiness models presented to you. As Lav mentioned, one is a recent model developed using artificial intelligence through the Ag8 Institute, and that's called Grape Hardiness, or that's just the name of the model that we use for presentation purposes on this particular website. And the other one is the WSU Cold Hardiness Model, or CHM. And this is a traditional model that we have been running on AgWeatherNet for about 13 years now. And so this is the model that many of you guys who have used the grape cold hardiness on AgWeatherNet in the past, this is the model you're familiar with. They're both really good models, and we're presenting both of them because they do show some slightly different information, but typically the information is not so drastically different that you would make a different decision. So that's important to note, but they are fun to kind of compare to how these two models perform. And just like anything or many other aspects to AgWeatherNet, once you get past that basic information for whatever model or page you're looking at, AgWeatherNet then allows you to customize your experience within that page. So just like everything else, you can select a weather station that's of interest to you. If you don't know the name of your station off the top of your head, you can click on the word map, and it'll open up a map of all the AgWeatherNet stations across Washington State, Oregon, and probably into Idaho. You can hover over where you are located. You can zoom in, find your favorite station, et cetera. And if you click on that, that will add that particular station to the list of stations you're going to look at. So I just clicked on Ritzville, and so suddenly it was added. If you are a very active user of AgWeatherNet and an active user of these models, once you add certain stations, they'll essentially already be populated there the next time you log in, which is a really nice feature. I'm actually going to remove the Ritzville station here so it doesn't clutter up our screen. The two other ways you can customize your grape cold hardiness model view after you select your station is to select the growing season. So right now we're on the current growing season, and then select the variety. Under growing season, we actually can go back until 2010, which is a really nice feature if you're looking for historical potential damage at a site. So you can scroll back through the number of dormant seasons. And there are about 23 different modeled grape varieties to select from. So no, not every single model. We don't have data for every single grape variety to do a model for that, but we do have data on these 23, and they are fairly representative of the major swings and types of cold hardiness that we see in some of the major grapes grown in Washington State. So once you have your growing season and variety selected is when you get to see the data output. So we're going to go through this graph first. So right now you can see I have 3 different stations that I routinely look at on this particular model. Right now we're looking at data from the weather station called Rosa 2. So that's right up here at the WSU Rosa farm. And you'll see a graph. And this graph is what contains all the information or that is modeled. A couple of things first. On this graph, if you look at the bottom, you'll actually see different things highlighted or not highlighted. These are all the different data points that you can view while on your graph. So I can click on dew point, and it can add the dew point line. We don't need to look at that. I can look at relative humidity, can add that. Here, minimum air temperature, that's pretty important relative to cold hardiness because it's usually related to minimum air temperature. And that's in the bright blue line that you see growing across your screen. And then we also can add in maximum air temperature if you want to. There's that red line. And then we have our different cold hardiness models. We have the Ag8 Grape Hardiness, where we can model what temperatures would need to be to get 10% bud damage, that's LT10, 50% bud damage, that's LT50, and that's the default orange line that's typically shown with your grape cold hardiness models. And then LT90, so I'm going to click on that, and hopefully that'll add, and that's a red line here. And that's the temperature at which 90% of the buds would be damaged. So those are your grape hardiness models. And then we have the exact same LT10s, 10%, 50%, or 90% lines using the WSU grape cold hardiness model. And currently the default is a slight green line, and that's the LT50. So as you hover along the screen, one thing you'll notice is that as temperatures slowly start to cool over the course of the dormant season, grapevine buds start to become more hardy. So the way you interpret this is, okay, right here, if you hover over this particular date, so on October 18th, the minimum air temperature was 32.9 degrees, but the predicted cold hardiness of Cabernet Sauvignon using the grape hardiness model was 13.5 Fahrenheit, and the predicted cold hardiness using the WSU model, it was the older WSU model, was 11.5 degrees Fahrenheit. So you know if the low temperature is much warmer than what those predicted cold hardiness values are, you will not have cold damage. And that's how you use the model. It's quite simple. What I really love about AgWeatherNet is not only are they showing current temperatures or past and current temperatures and modeled cold hardiness, they also are showing forecast lines. So you'll notice these will be dotted lines on your graph, and that'll allow us to look ahead to see, are any forecast overnight low temperatures cold enough to potentially cause damage? So you can see that with these forecast lines. And so they forecast the temperature, and then using that forecast temperature, they then predict cold hardiness with both of the models. A couple other features specific to this page. Say you're having a hard time, as the season progresses, more data is starting to shows up on these screens, and that can be a lot to look at. You can actually drag your mouse and highlight certain areas to zoom in. Unfortunately, it doesn't look like mine is wanting to zoom right now, so maybe we'll go to another model. But typically you can there we go. If you highlight over some data, you can zoom in, and if you notice, suddenly we're really scrolled into that particular time period, and you can go back out by hitting reset. So that's a nice little function. And then, of course, as I mentioned, and I can't point, unfortunately, and then also move my mouse because it will change. But you will notice when you hover over a particular date, will provide minimum air temperature and then your predicted modeled cold hardiness in numbers. When you go to the current date, there's a lot of information shown there, and I wanted to walk you through that. On the actual current date, the data you'll see is the current minimum air temperature. You will see the current Grape Hardiness LT 50% bud damage values. Then you'll see a bunch of things labeled FC, and that's forecast. And so that's telling you what the forecast minimum temperature is, the forecast Grape Hardiness, and then the forecast, which is the last one, sorry. The last one here is the forecast WSU cold hardy values. And then, of course, in the middle, there is the estimated current WSU cold hardiness LT50 values. So there you go. That's what we see on this main graphic. As you scroll down the page, essentially once risk, if a cold event actually has occurred or is in the forecast to occur, this risk area will indicate that. Unfortunately, it's really warm right now, so there is no risk. So all we see is no potential damage forecast. So if there is potential damage, though, this would light up. If you want to refresh your brain on what you're seeing on this chart, the chart elements tab, if you click on that, it'll tell you what solid lines, dotted lines, and hashtag lines are. I'm going to do an example of what this is in a little bit. And then chart actions. All those things about zooming, hovering, etc., are all available under the term chart actions. And then ultimately, the goal is to use this information to predict or to adjust our pruning practices in grapes. And there's a direct link to some management guides, but I'll show that here in a little bit. But I wanted to show you what this graph would look like if damage actually happened. So I'm going to change some things around here. We're going to look at this as we're currently looking at now the College Place weather station. So for those of you that are not familiar, this is in Walla Walla. We're going to look at last year because it got pretty cold last year in January. So we're looking at Cabernet Sauvignon in January, and I want to show a couple things, and we're going to look at another variety called Grenache as well. And so this is for Cabernet Sauvignon in January of 2023 to 2024. So this is 1 year ago in Walla Walla, and you will notice right around January 13th, the minimum air temperature was negative 9.2 degrees Fahrenheit, and the Grape Hardiness model said cold hardiness for LT50, so the temperature at which 50% of Cabernet Sauvignon buds may die, was at negative 8.2. So the actual air temperature got colder than the predicted LT50 or the 50% bud damage mark. And as what you'll see is there's this slashed line that has shown up on the graph, and that's telling you that's a time point at which potential damage may have occurred. If we pick a particularly sensitive grape variety, Mourvedre, if we look at that, you start to notice same thing. Another hashed line has occurred, and this time you see even more hashes behind that. So it's both yellow and green, indicating some severe cold damage. And this is obviously cold damage was met using both models. So both the WSU cold hardiness model and the Grape Hardiness model both indicated that potential risk was going to be there. So that is something to look at. So it's a really nice feature to kind of go back in time and look at potential cold damage for different sites and varieties. All right, so say you're in this situation, you were a grape grower in Walla Walla, you grow Mourvedre. It's now January of 2024. You've had cold events. What do you use this information for? Well, the reason or the way to use the Grape cold hardiness model is to then say, okay, damage may have occurred. Now it's time to go out into the vineyard and actually see if that damage was realized. So this model helps you better time potential activities such as grapevine bud cutting and pruning. So whether or not you should spend extra time checking buds for damage, or whether you need to hold off on your pruning practices and wait as late as possible into the spring before you actually make a pruning decision. And what to do with those pruning decisions is not listed on AgWeatherNet. They're just providing the means to help you make a decision. But we at WSU Viticulturology actually have those decisions or additional decision support on what to do next. So if damage has occurred in your vineyard, and AgWeatherNet, the grape cold hardiness models also show that, hey, you might be dealing with some damage, we recommend you navigate to the wine.wsu.edu website, go to our extension tab, and so that's just clicking on the word extension, and then jog down to our grapevine cold hardiness tile. And if you click on that, that will take you to resources related to grapevine cold hardiness. And so on our grapevine cold hardiness page, you'll see resources on how to prevent cold damage. So these are more for what you should do to help prevent damage from actually happening to your vines. But then we also have resources on if damage has already occurred, then what do you do? This includes ways to check to see if that predicted cold damage was actually realized. And it also provides additional tips and tricks on how to adjust pruning in your vineyard to compensate for potential bud loss and fruit loss. For those who are super interested, we also still do real-time cold hardiness monitoring here at WSU, where we take grapevine buds, put them in a freezer, and figure out what temperature they're actually frozen at. This information actually feeds in to the AI model used, the Grape HardiNet model on AgWeatherNet, to help improve that every year. And we do post those real-time data points here on our website, but they're only specific to Prosser and to the varieties that we're showing. So that's why we have these models, is because we want something to be a bit more universal across the state. If there happens to ever be a major cold event like there was this past winter, this website also changes to reflect what that cold event means, and it draws your attention to the resources on how to respond to that particular cold event. So the two major websites here, AgWeatherNet, Grapevine Cold Hardiness Model, to figure out if damage might have occurred in your vineyard or is forecast to occur. And then if that's the case, jump over to wine.wsu.edu to access our resources on how to respond to that cold hardiness or to that potential cold damage. So Lav, I believe that's all you wanted me to discuss. I'm going to stop sharing my screen and jump over to Gwen to talk about blueberries.
I get to skip a lot of things because Michelle went first. I am going to go through this. So you're in the blueberry, same thing Michelle said, and then you're going to click to the blueberry cold hardiness. And it has a very similar look, very intentionally, but the information's a little bit different. So we don't have an AI model and two different models we're showing one, but in that, because the physiology is different behind grape buds and blueberry buds and cold hardiness and so forth, and even how they are able to super cool, we really felt was important was these first three key factors at the top. So again, the information about the model is up at the top. For us, there's three key factors. Knowing the average lethal temperature, that's the number that you're going to get on the graph that Michelle went through. Then we have to know the range of damage that can occur. And that is, so see this link down here, it says range of damage across fields. And in this first one, it's how to use LT. So I'm going to go through both of those so I kind of walk you through. So knowing your average lethal temperature, you would click on this one. And what it tells you is that the number that's presented below, we have 7 years worth of research data on 4 different cultivars, but the model accurately predicts LT50 within plus or minus of about 4 degrees Fahrenheit. So when we were going through and talking with growers, sometimes they would take an LT number on some models and they'd plus or minus 1 degree. Some people were plus or minus 10 degrees, 7 degrees. Our goal was to get this under 5 degrees. So just be aware that there is some variability within there and some error. So if I close that up and I go to number 2, which is knowing the range of damage that can occur, what we did is we said that there's a lot of variability in the field. And there's a lot of things that could affect cold hardiness, including your nutrition, if you've overcropped, if you have over-fertilized, if you have lots of weak wood, thick wood, etc. There's a lot of things that can affect cold hardiness. So one number doesn't do it for all blocks. It just doesn't happen that way. So what we've taken a very conservative approach, and we have a table, and I'm hoping that when you guys look on yours, the print will be bigger, right, for what you might be able to see right now. But I'm only going to give you one example of this Duke where it says 0 to 45%. So if the temperature drops to a predicted level of an LT10 in a Duke field, then we predict, or we would expect 10% of the flower buds to die across all fields, right? But any single field can vary between 0 to 45% death. But what we know is that 90% of the fields within the state of Washington will experience will experience 10% mortality. So that 0 to 45 is a wide range, but it's kind of what leads us to the fact that you have to know your block and you have to start getting data in your block. And I've heard this with lots of other cold hardiness models, phenology models. We look at codling moth models. How come the codling moth model is different than what I'm finding in my traps? Well, there's lots of reasons. It's a mathematical model. It's giving you a best prediction, but it isn't always what's happening in your block, right? So that leads me, I'm going to shrink this up. That leads me to the third one, which is assessing how your fields will vary from the average. So I'm going to go all the way through this. And at the end, I'm going to say, so what happens if you think you have damage? And I'm going to show you a video that you can look at. If you're getting close to where it's assessing that you would have had damage, then you need to start saying, or you didn't think you were close, but you did get damage. You need to start assessing it and reporting it because you need to know, just like you would take an ag weather net station, you say, oh, the weather is supposed to be this, but I'm always a little bit warmer, or I'm always a little bit colder. This is the same thing. So it's saying, hey, my LT is predicted to be LT10, but I know I'm always a little bit more hardy than what that is, or I'm always a little less hardy. You have got to get some site-specific information about your block so that you have a better way to guess. And if you do this year after year, you can see how much better you would have a precision cold hardiness management per block with this extra data. So when the model is saying this, it's not gospel, it's its best estimate based on the whole industry. Now you have to dial it down into your block and how does it relate to the numbers that are in the mathematical model. Very much like what Michelle said, you can select a station, map. We have seasons. We have 4 cultivars. So it's Duke, Liberty, Aurora, Draper. The reason those cultivars were selected is because at the beginning of this cold hardiness process, the Washington State Blueberry Commission had advisors. Those are the 4 cultivars they chose. But across the bottom here, same kind of concepts at the top. I have Benton City, Pasco, Prosser, and Snipes is the one I've chosen. If I scroll down, a little less options to turn things on and off. You can get them highlighted, but we show LT10 number, which is yellow, LT50, which is orange, and LT90, which is red, and the minimum air temperature is blue. So similar to the forecast, it's dotted line. We have solid lines being now. Right now, where we are from September to November, it looks like a flat line. I'm going to show you in another step where it sort of, again, models that whole curve. If we look at a whole season, you're going to see where it's acclimating to the cold, it becomes pretty steady in the winter, and then it deacclimates in the spring. So I'm going to switch to 20, 21, 22, Duke. Okay, Benton City. So here you have it pretty flat lined. And then in November, it gets a little bit colder. And then you can see in the spring, it warms up. And so you get this mild U-shaped curve. What is really noticeable when we first started planting blueberries in the valley, there was a lot of cold hardiness management. We put wind machines on, heaters, etc. Sometimes in early winter, sometimes midwinter, we would burn a lot of propane in that respect. If I go through almost any station of any year that we have history on, there's almost no midwinter damage on these 4 cultivars. These cultivars are all really relatively true high bush blueberry. When we start putting in varieties that have southern high bush, it's going to be a different story. These are all northern high bush blueberry varieties. And what's really cool is that we've seen midwinter hardiness. When we warm the air, we're actually taking them slightly out of their dormancy. We don't need to do it. So it saves us money, better for our communities. But you can see where there are times like in the spring. So in April 9, 13, 17, that's a time when they started to get close. There's a plus or minus 4 degree. Going to be looking at it during that time period where you start to maybe have thought, hey, I wonder if there's going to be damage that's out there. Spring is our most sensitive time because we get such fluctuating weather. That's right when all the blueberry flowers are coming and blooming. And so that's the time it's most sensitive. So if you end up with a period like that, we have this session here, what to do if you suspect damage. So if the minimum daily temperature approaches any of those of the lethal temperature, we suggest that you assess your damage in your field. This helps you. If you get this recorded, this helps you with understanding what your long-term seasonal fluctuation is based on what our model is. So the Good Fruit Grower, I'm not going to show this video because you guys can watch it, but the Good Fruit Grower and I created a video on how to cut buds. You're going to take shoots from a single cultivar in a similar field. Please do not mix Duke and Liberty and put them all in one sample and say, oh, it's an average. Or you take something that's, you have a very steep slope and at the top of the hill and the bottom of the hill, and you know that there could be a temperature difference. Or you have two completely different strengths of cultivars. So if you have a block that you know is struggling in pH or fertility and is scraggly, or you have one that's really got a lot of great strong looking red canes, those will have different cold hardiness and damage levels. Usually the weaker the twig, the less cold hardy it is. So really separate this out into true samples. And then there's a method that you can see there where you would cut the buds, you're going to assess it and then compare. If it was getting close, did you have any damage? Was it about LT10? Was it LT30, etc.? Record it, keep it for your management decisions later. This work was completely funded by the Washington Blueberry Commission. We did do the work in multiple different locations from Prosser, Patterson, Linden, Mount Vernon. So it does cover across the state. So if you're in Western Washington or Eastern Washington, the data is still valid, really different patterns. And you have to kind of know bloom is at different times, March versus April, etc. But it is fairly widespread. So with that, I kept mine shorter because Michelle was going to cover longer of it. So Lav, I don't have a whole lot else to cover with that aspect of it.
No, this is good, Gwen. Thanks. So let's go to Shrikant now to get some quick updates on the air versus bud temperature sensing, I guess. Shrikant, you're there?
Yes, Dr. Good. Hi, I'm Shrikant. Today I'll talk about air and bud temperature sensing in cherries and blueberry. I'm a grad student and this study was funded by CPS, NIFA, USDA. Let's get started. Michelle and Gwen has mostly covered about frost damage. I don't want to spend most of my time here, but usually in spring we have this cold hardness charts where we have different lethal temperatures like 10%, 50%, and 90%. In spring, we usually look at forecast and then growers usually arm their wind machines or sprinklers or propane heaters based on LTE10. They do not want to usually get 10% damage. Threshold temperature will be usually higher than that. So what we wanted to do is we wanted to look at the differences between the air temperature and what the actual bud is experiencing. There was a literature out there which has studied about bud and air temperature differences, but in cherries and blueberries, there was no any research or any sensing has been done earlier. So as we can see in this figure, this is a thermal image taken during the morning. And at that time, the air temperature was around 37.8. Cherry buds are relatively cooler than what we measured through a typical air temperature probe. The major challenge with regards to bud temperature tissue temperature sensing is we do not have any adequate sensing tools. For example, like we have a thermocouple which we could insert it, but it doesn't stay long inside the bud, or it might damage the bud. So we need to change the bud every now and then. We are trying to look at these aspects, how we could improve bud temperature sensing so that we could potentially reduce the error from the cold hardness models. What we did was for 3 years, we collected data in sweet cherries and 1 year in blueberries. We installed an air temperature humidity probe and then at eyesight, which is standard weather measurement. So we collected data for every 5 minutes, and at the same level, we also installed thermistor, like it's a disc which actually mimics plant leaves. So this sensor was from a company called Apogee Instruments. So it's a commercial grade sensor. We just try to collect the data from that to understand how the data varies when we have like radiative frost night and how it compares to the air temperature sensor. Then we have these thermistors which are inserted into the buds. This was very difficult for us to maintain because sometimes we damage the buds or sometimes they just come out. So we have to rotate them every now and then, probably every week. Sometimes it used to be like 3 or 4 days. When there is like little bit breeze or strong wind gust, sometimes they used to, come out. So we have to try to maintain that consistency by changing the buds every now and then. This is also a commercial grade sensor from Apogee Instruments. It's a thermistor which is very thin. It's of a needle size, so it's very small and it's perfect for measuring the bud temperature. These buds are selected at around 5 feet above the ground level range because you do not want to go too high or too low. So as we can see, this graphs actually depict the offset between bud tissue temperature, which is TC, and radiative frost sensor, which is TRF, compared to the typical air temperature that we usually measure. What we observed was there was an offset between these variables, especially between air temperature and radiative frost sensor. It was little bit higher because the sensor itself has larger area compared to typical bud, and it usually loses more heat during a frost night and it gets cooler very fast. Similarly, in blueberries, we observed around 1.4 degree Fahrenheit difference for overall spring season between air temperature and bud tissue temperature. We looked at the night time or the temperature when it is minimum. We also wanted to look at what happens during the morning. This is a time series graph. As we can see, like during morning time, there is sunlight which is coming onto these buds and it's heating them up. As you can see, especially like around noon time, the bud tissue temperature, which is TC, is higher than air temperature. This might accelerate the process for the buds to lose cold hardiness because they are experiencing higher temperature than what we usually measure using an air temperature probe. We also looked at maximum daily temperature variation because most of these cold hardness models use maximum air temperature and minimum air temperature as one of their predictors. So we wanted to look at what is the difference between maximum air temperature, maximum bud tissue temperature, and maximum radiative frost sensor temperature. As we can see, for overall 3 years, we looked at the maximum temperature for using radiative frost sensor was around 110.77, but with air temperature, it was only 85.71. There was a significant difference between these variables, and it might induce fast acceleration for the buds to grow because the bud tissue temperature itself is around 7 degree Fahrenheit higher than air temperature. This might be due to direct sunlight interception on these buds, which might explain the significant differences on the maximum daily temperature. If cold hardness models could use this bud tissue temperature, probably the error might reduce on how they are predicting. But we are also looking at developing a bud tissue temperature model, which we could use instead of inserting a thermistors or probes inside these buds and trying to maintain their consistency. That's an ongoing effort from WC side. There is one more outcome for this project as from AgWeatherNet Tier 3 program. So this is a pilot development that we are doing. We are trying to build ecosystem for low cost LoRaWAN sensing. So LoRaWAN is basically a radio network which works on different protocol, and it can basically relay data for at least 13 miles. That's the maximum limit that you get. We deployed sensors at different locations inside the orchard, as you can see here. And typically at lower elevation, we observed lower temperature. There was around 2 degree Fahrenheit difference between a point temperature at lower elevation compared to higher elevation. And also we user can select like various variables that they want to see. For the past day, they can look at the time series trends that these variables have. Like for example, if you select any of the nodes, you can see how these variables are changing with respect to time series. That can give you an idea about how the temperature variation is happening at different locations throughout the night. Thank you.
Thank you, Shrikant. And again, on the Tier 3 program, we have been accepting the weather stations from the grower side of things. And then, as Shrikant showed in last slide there, we'll be accepting these LoRaWAN enabled temperature humidity probes or similar flow sensors that are compatible with LoRaWAN time series sensing, SD12 type scenarios there. But we'll have more on this. Besides frost, we can also have this similar ecosystem used to monitor the heat stress in the orchards and such. And then again, irrigation, water flow and all that. So we'll have more on this after December. I think Shrikant will have more finished ecosystem that we can demo and all that. Yeah, thanks again for joining. And again, I want to thank Michelle, Gwen, and Shrikant for doing the presentations. But again, thanks. Yeah, this is great.